Hello everyone, welcome back. My name is Harley from the Play, and we are back in the Odin project. We're going to continue on for just a little bit longer. Not too much longer, maybe like another 30 minutes, and then it is bedtime. Okay, so now, since we have all of the files, right, we can go ahead and go through this little Unix shell course that the Odin project provided for us. So we gone through how to download and what we're going to be doing, and now we're actually going to be looking at stuff. So okay, navigating files and directories. Excuse me. So let's take about 30 minutes to teach and a 10-minute exercise. How can I move around on my computer? How can I see what files and directories I have? How can I specify the location of a file or directory on my computer? And then explain the similarities and differences between a file and a directory, and translate an absolute path into a relative path and vice versa. Construct absolute and relative paths to identify specific files and directories. Use options and arguments to change the behavior of a shell command. And then demonstrate the use of tab completion and explain its advantages. The part of the operating system responsible for managing files and directories is called the file system. It organizes our data into files, which hold information, and directories, also called folders, which hold files or other directories. Several commands are frequently used to create, inspect, rename, and delete files and directories. To start exploring them, we'll go to our OpenShell window. Oh yeah, let me make sure I'm off the Wi-Fi here. There we go. First, let's find out where we are running a command called pwd. First, let's find out where we are by running a command called pwd, which stands for print working directory. Directories are like places. At any time while we are using the shell, we are in exactly one place called our current working directory. Commands mostly read and write files in the current working directory, i.e. here. So knowing where you are before running a command is important. pwd shows you where you are. pwd, so we are in home and into our, that's what I was trying to show y'all earlier. But then it shows us where we are, right? So home has user. So there we go. Here the computer's response is users nel, which is nel's home directory. The home directory path will look different on different operating systems. On Linux it may look like home nel. On Windows it will be similar to CE documents, right? Or note that it may look slightly different to those slightly different for the different versions of Windows. Sorry. In future examples, we've used Mac output as a default. Linux and Windows output may differ slightly, but should be generally similar. We should also assume that your pwd commands return your user's home directory. If pwd returns something different, you may need to navigate there using cd, or some commands in this lesson will not work as written. See exploring other directories for more details on the cd command. And then can obviously click that. Oh, I think this is actually in the, yeah, we don't even have to worry about that because we're going to get to it. Okay, to understand what a home directory is, let's have a look at how the file system as a whole is organized. For the sake of this example, we'll be illustrating the file system in our scientist Nell's computer. After this illustration, you'll be learning commands to explore your own file system, which will be constructed in a similar way, but not be exactly identical. On Nell's computer, the file system looks like this. A home, and then their data, right? At the top is the root directory that holds everything. Or okay, that's their root directory. We refer to it by using a character / on its own. This character is a leading slash in users nel. /users /nel. Inside the directory are several other directories. Bin, which is where some built-in programs are stored. Data, for miscellaneous data files. Users, where users' personal directories are located. TMP, for temporary files that don't need to be stored long-term, and so on. We know that our current working directory is /users/snell is stored inside /users because /users is the first part of its name. Similarly, we know that /users is stored inside the root directory / because its name begins with the /. That's a lot of forward slashes. Notice that there are two meanings for the character, for the / character. When it appears in the front of a file directory name, it refers to the root directory. When it appears inside a path, it is just a separator. Underneath, we will find one directory for each user with an account on Nell's machine. Her colleagues, Imhotep and Larry. The user's Imhotep files are stored in /users /Imhotep. User Larry's is in /users /Larry, and Nell's in /users /Nell. Because Nell is the user in our example here, therefore we get /users /Nell in our home directory. As our home directory. Typically, when you open a new command prompt, you'll be in your home directory to start. Now let's learn the command that will let us see the contents of our own file system. We can see what's in our home directory by running ls. And there we go. We get an output. Again, your results may be slightly different depending on your operating system and how you have customized your file system. ls prints the names of the files and directories in your current directory. We can make its output more comprehensible by using the let's just say -f option, which tells the list to classify the output by adding a marker to file and directory names to indicate what they are. A trailing / indicate that can't even talk. A trailing / indicates that this is a directory. The @ symbol indicates a link. The star symbol indicates an executable. Depending on your shell's default settings, the shell might also use colors to indicate whether each entry is a file or directory. Okay, so this is blue for us. So we're going to do lsf. Here we can see our home directory contains only subdirectories. Any names in our output that don't have a classification symbol are plain old files. If your screen gets too cluttered, you can clear your terminal using the clear command. You can still access previous commands using the up and down arrow to move line by line, or by scrolling in your terminal. Getting help. The list has lots of other options. There are two common ways to find out how to use a command and what options it accepts. And just to relook, ls in command shell. ls is a shell command that lists files and directories. Anyway, it's just a list command. Cool. Okay, ls has lots of other options. There are two common ways to find out how to use a command and what options it accepts. Depending on your environment, you might find that only one of these ways works. One, we can pass a --help option to the command, not available on Mac as such. So ls-help, and it opens up this manual, and we can read its manual with man. So let's see how this one looks. Man ls, and then this gets us okay, sorry. And man, okay, so this tells us about each one. So the --help option Most bash commands and programs that people have written to be run within bash support a dash dash or hyphen help option that displays more information on how to use a command program. So when you type it in, it gives us a list of options, right? If you try to use an option that is not supported, ls and other commands will usually print out an error message. So it just tells us man tt, right? Oh. So it does give us something. Okay, so it gives us that's cool. It actually gives us an information on it. ls list directory. Oh, gotcha. And then it gives us a list of all things that we can list. Excuse me. So it says here, if we try the ls-j command, it'll tell us that it doesn't exist. And the man ls, right, gives us this pretty much a booklet that we can go through, so we can navigate line by line with the arrows, and we can move B is the space to go down, B to go up, and then to search a character or word in man pages, we can use hyphen followed by the character or word. So we can do that in D, right? And then it'll highlight what we want here. So we can do that to write commands to give us a result. And so you can move between hits using in. And shift in to move backwards. So that's cool. Alright. And then we can press Q to quit at any time. Of course, there's a third way to access help commands, but that's with the Unix thing, and we're not going to worry about that. Exploring more ls flags. You can also use two options at the same time. What does the ls do when used with the -l option? What about if you use both the -l and the h option? Some of its output is other properties that we do not cover in this lesson, such as file permissions and ownership, but the rest should be useful nevertheless. So let's do right, and let's go look up. Oh, actually, I like the other way better. Right, and then we can look up -l, and let's search. Next, there we go. Use a long listing format. So it's going to list a long list, and what is the -h? So human readable. So with -l and s, print sizes like 1K, 240, 234 M, 2G, etc. Okay, so let's try it. So we can do ls-lh. What does that do? Right, because let's see what this does, right? Okay. So I see it now. Okay, so just the -l did this, and that did that, and let's see. ls-h, what does that do? Nothing. I guess it lists it by whatever. So when we do 2, it does it like that. Okay, that's pretty cool. So the L option makes the ls use a long listing format, showing not only the file directory names, but also additional information, such as the file size and the time of its last modification. If you use both the -h option and the L option, this makes the file size human readable, i.e. displaying something like 5.3K instead of 5,369. By default, ls lists the content of a directory in alphabetical order by name. The command ls-t lists the items by time of last change instead of alphabetically. The command lsr lists the contents of a directory in reverse order. Which file is displayed last when you combine the -t and -r options? Hint, you may need to use the L option to see last change states. So we already did an L, right? So desktop is when we last changed dates. So time of last changed and reverse order. So it's going to go by time, which is going to be desktop. Oh. Okay, so we're going to list it by time. So, right, and then in reverse order. Gotcha. So the last things that were messed with to the most recent. There we go. The most recently changed files listed last when using -RT. This can be very useful. That's cool. Exploring other directories. Not only can we use ls on the current working directory, but we can use it to list the contents of a different directory. Let's take a look at our desktop directory by running ls-f desktop. So let's clear everything first, right? So you just type clear and it clears, and then desktop. Alright. Let's take a look at the desktop and then, okay. The command ls with the -f option and the argument desktop. So we're declaring an argument here. The argument desktop tells ls that we want a listing of something that other than our current working directory. So we want to list something from a different directory. So we argue it into the command. Okay, so note that if a directory name desktop does not exist in your working directory, this command will return an error. Typically, a desktop directory exists in your home directory, which we assume is the current working directory of your bash shell, which it is. We're in our, and we can check that again as well by typing pdw or pwd. Sorry, but let's do that again. -f desktop. Alright. Your output should list should be a list of all the files and subdirectories in your desktop directory, including the shell lesson data directory you downloaded this at the setup for this lesson. On many systems, the command line desktop directory is the same as your GUI desktop. Take a look at your desktop to confirm that your output is accurate. As you may now see, using a bash shell is strongly dependent on the idea that your files are organized in a hierarchical, god dang it, cannot speak. Organizing things hierarchically. I don't know, I'm tired, but in this way helps us to keep track of our work. It's possible to put hundreds of files in our home directory, just as it's possible to pile hundreds of printed papers on our desk. But it's a self-defeating strategy. Now that we know that shell lesson data directory is located in our desktop directory, we can do two things. First, we can look at its contents using the same strategy as before, passing a directory name to ls. So -f desktop / shell lesson data. The second, we can actually change our location to a different directory, so we are no longer located in our home directory. The command to change location is cd, followed by a directory name to change our working directory. cd stands for change directory, which is a bit misleading. The command doesn't change the directory, it changes the shell's idea of what directory we are in. The cd command is akin to double-clicking a folder in a graphical interface to get into a folder. Let's say we want to move to the data directory we saw above. We can use the following series of commands to get there. So, cd desktop, and it's showing you here that you can go like that, but you can also just go through all of it too. So, data, and then we want to go into exercise data, so exercise data. Boom. Now we're in exercise data. So, since we're just working in this for now, we can do half and half, right? Let's zoom in one more time. Whoa, buddy. Okay, no, let's zoom out. We lied. We don't need that. We don't need that. There we go. Okay, let's clear. Alright, so now we know where we are, right? We're in the desktop shell lesson, and let's print it on the screen. Right, now we know where we are. These commands will move us from our home directory into our desktop directory, then into shell lesson directory, then into exercise directory. You will notice that cd doesn't print anything. This is normal. Many shell commands will not output anything to the screen when it's successfully executed, but if we run pwd after it, we can see that we are now in user nil desktop shell lesson exercise data. Boom. Just like we did right there. So pwd checks. Okay, so now what we can do is we're going to list another command. What do we have in here? So we have 4 files and a text file. We now know how to go down the directory tree, how to get into a subdirectory, but how do we go up, i.e., how do we leave a directory and go into its parent directory? We might try the following: cd shell lesson data, cd shell lesson data, bash cd shell lesson data, no such file or directory. But we get this error. With our method so far, cd can only see subdirectories inside your current directory. There are different ways to see directories above your current location. We'll start by using the simplest. There's a shortcut in the shell to move up one directory level that looks like this. So that's important. cd ... and we go up one directory. There's a special directory name, meaning the directory containing this one, or more succinctly, jeez, got some advanced words for me. My brain can't handle this. Yes, it can. Yes, it can. Okay. Or more succinctly, the parent of the current directory. Just to make sure we're saying this right. Okay, like instinct.
Succinctly.
Succinctly. Okay. Cool. We're saying it right. Hey, don't ever be afraid to use Google. Google is your best friend. Okay, so cd ... goes up a directory. Okay, so we don't need a... Okay. The special directory ... doesn't usually show up when we run ls. If we want to display it, we can add the -a option. Okay, hold on. Okay, so they want us to do the -a option with it. So it lets us know that we have. So what if we go cd dot? No? Okay. I was just saying, so. Okay, so you can also do it like that. I was just saying if you're able to just do it all in one instead of having to do it two separate. Okay, -a stands for show all. It forces a list to show us file and directory names that begin with dot, such as ... Show us file and directory names that begin with dot, such as ... which if we're in users now refers to users directory. As you can see, it also displays another special directory that's just called dot, which means the current working directory. It may seem redundant to have a name for it, but we'll see some uses for it soon. Okay. Note that in most command line tools, multiple options can be combined with a single hyphen, and no spaces between the options. Okay, cool. That's what I had did. So ls hyphen f and a hyphen a is equivalent to ls hyphen fa. So, in addition to the hidden directories ... and ... you may also see a file called .bash profile, which I don't think I did. This file usually contains shell configuration settings. You may also see other files and directories beginning with the dot. These are usually files and directories that are used to configure different programs on your computer. The prefix dot is used to prevent these configuration files from cluttering the terminal when a standard ls command is used. These three commands are the basic commands for navigating the file system on your computer: pwd, ls, and cd. Let's explore some variants of those options, or those commands. What happens if you type cd on its own without giving it a directory? So let's do it. cd, and then it took us all the way back to our home, and then pwd, boom, we're back in our user. It turns out that cd without an argument will return you to your home directory, which is great if you got lost in your own file system. Let's try returning to the exercise data directory from before. Last time we used 3 commands, but we can actually string together the list of directories to move to exercise data in one step, which is what I actually did because I didn't feel like doing it 3 times. So we'll type it in. Boom, and then we get there. pwd, and then we'll run an ls-f, and then boom, we're back to where we were, where we can see our what we have. If we want to move up one level, we see cd ... but there is another way to move any directory regardless of your current location. So far, when specifying directory names or even directory path as above, we have been using relative paths. When you use a relative path with a command like ls or cd, it tries to find that location from where we are rather than from the root of the file system. However, it is possible to specify the absolute path to a directory by including its entire path from the root directory, which is indicated by leading slash. The leading slash tells the computer to follow the path from the root of the file system, so it always refers to exactly one directory, no matter where we are when we run the command. This allows us to move to our shell lesson data directory from anywhere in the file system, including from the inside exercise data. To find the absolute path we're looking for, we can use pwd and then extract the piece we need to move to the shell lesson data. So we're going to do pwd right? And then we're going to be in our exercise data, but we want to go to shell lesson data. Run pwd. Okay, so cd home, right? Hold on, we messed up. I was trying to do something, but it didn't. Okay, so we're gonna go cd home dev desktop. Okay, cool. So what I was doing is I was typing a small portion of what the file I was trying to get to, and then hitting the tab key, and that gives us it auto fills our selection. And then we'll run pwd again, right? And then we'll run an ls-f, and then boom, we're. The shell interprets the tilde key at the start of the path to mean the current user's home directory. For example, if now's home directory is user now, then tilde / data is equivalent to user's now data. This only works if it is the character in the path. Here, there, elsewhere is not here, there, users, no, elsewhere. Another shortcut I'm gonna try that. So cd back, and let's go. Gotcha. So I'd have to go like that. No? Hold on. Okay, I guess I'm just tired. I'm not interpreting that correctly. Okay, the shell interprets a tilde character at the start of a path to mean the current user's home directory. For example, if Nell's home directory is user's now, then tilde data is equivalent to user's now data. This only works if it is the first character in the path. Here, there, that tilde key, elsewhere is not here, there, users, now, elsewhere. Another shortcut is the dash character. cd will translate dash into the previous directory I was in, which is faster than having to remember then type the full path. This is a very efficient way of moving back and forth between two directories, i.e., if you execute cd twice, you end up back in the starting directory. The difference between cd ... and cd hyphen or dash is that the former brings you up, while the latter brings you back. Try it. First, navigate to. Okay. Oh, I was doing it wrong. So now if you run CD, it takes us up to the last one we were at. That's cool. Cool. I like that. I think we're almost done. You'll see your backend desktop. Show lesson data. Run CD -again, you're back. Okay. Absolute versus relative path. Starting from which of the following commands could Amanda use to navigate to your home directory? Which is user Amanda. CD would be, but okay, so CD dot, I don't remember what that one does. Nothing. Okay, so that wouldn't work. CD / should work. CD home, that should work. I don't know if that would work. Don't think so. That could work. That could work. No. Yes. No. Oh, okay, so yes, so no. Oh, okay, so no. No. Oh, okay, gotcha. No. Says user home directory, so that one would work. Which one is that? 6. Oh. Okay. Using file systems diagram, if PDW displays user's thing, what is ls-f backup display? Backup, it's going to display the files. Yep. And then using file system below to the list. Okay. So we tell it to do it in reverse, so it should go sub first and then final and then original. Oh. It's asking which one of those would give that. So that'll be LSFR. Oh, okay, so that uses it explicitly to show. Okay, general syntax of shell command. We have now encountered commands, options, and arguments, but it is perhaps useful to formalize some terminology. Consider the following below as a general example of a command, which will dissect different parts in a little bit. So let's be clear and let's try lsf /. There we go. So at was is a link, star is executable. Okay, ls is a command with an option -f and an argument /. So this should list everything in our root, I believe. We've already encountered options which either start with a single dash or 2 dashes, and if they change the behavior of a command, arguments tell the command what to operate on, and files and directories. Sometimes options and arguments are referred to as parameters. A command can be called with more than one option and more than one argument, but a command doesn't always require an argument or an option. You might sometimes see options being referred to as switches or flags, especially for options that take no argument. In this lesson, we will stick with using the term option. Each part is separated by spaces. If you omit the space between ls and -f, the shell will look for a command called ls-f with no space, which doesn't exist. Also, capitalization can be important. For example, ls-s will display the size of files and directories alongside the names, while ls-S will sort the files and directories by size, as shown below. So cd tilde desktop and shell data. Boom. ls-s exercise data. So I guess this is a count. We'll display the size of files and directories alongside the name. So total 20. 4 animals, 4 creatures, 4 numbers. And then ls capital S exercise data. Animals counts creatures. And a list directories by size. And we just do ls. ls exercise data. Okay. Putting all that together in our command above gives us a listing of files and directories in the root directory, an example of the output you might get from the above. Nell's pipeline organizing files. Knowing this much about files and directories, Nell is ready to organize the files that the protein assay machine will create. She creates a directory called North Pacific Gyre. Okay. To remind herself where the data came from, which will contain the files and data files from the assay machine and her data processing scripts. Each of her physical samples is labeled according to her lab's convention with a unique 10-character ID, such as NEO or the NEO1729A. This ID is what she used in her collection log to record the location, time, depth, and other characteristics of the sample. So she decides to use it as part of each data file's name. Since the assay machine's output is plain text, she will call her files letters and numbers .text, and so on. All 1,520 files will go into the same directory. Now her current directory shall list data. Nell can see what files she has using the command. The command is a lot to type. She can let the shell do most of the work through what is called a tab completion. If she types ls-nor and hits tab, ls-nor hits tab, boom. tab again does nothing because since there are multiple possibilities, pressing tab twice brings up a list of all the files. If Nell adds G and presses tab again, she will append goo. So let's try that. So ls nor G. Okay. To see all those files, you can press tab twice more. This is called tab completion, and we will see it in many other tools as we go on. The file system is responsible for managing information on the disk. Information is stored on files, which are stored in directories, folders. Directories can also store other directories, which then form a directory tree. PWD prints the user's working directory. Prints the user's current working directory. LSPath prints a listing of a specific file or directory. LS is known on its own, lists the current working directory. CDPath changes the current working directory. Most commands take options that begin with a single hyphen or dash. Directory names and a path are separated by a / on Unix, but / on Windows. And / on its own is the root directory of the whole file system. An absolute path specifies a location from the root of the file system. A relative path specifies a location starting from the current location. Dot on its own means the current working directory. Dot means the directory above the current one. Gotcha. Okay. Now we're going to learn about creating directories. But for now, I want to say thank you all for tuning in. I appreciate it. Leave a like and a comment down below to kind of help the series keep going. We need to thrive and push forward and become awesome people. But anyway, thank you guys for tuning in. Appreciate it. I hope to see you sometime tomorrow. Take care. Happy coding.